morning, ma'am. I have a question.
Yes, please. Let me. I need to get 2 students coming. Yes, please.
Yeah, my question is concerning the midterm exam that's coming up.
The exam, yeah, the exam we set up on March the 4th. What is your question? Is it March the 4th?
The 5th of March. That's what.
March the 5th, is it?
Yeah. So because I'm new to the system, so I don't really know how is it like when we assess it, that's when the time start counting, or we have the access to like go through the question, then
What do you mean? March the 5th.
yeah.
So it's next Friday, not this week's Friday, next week's Friday.
Yes.
Next week's Friday. So it's that exam section will open on the Friday's midnight, 12 a.m. And you can pick any time during the day. So you can start to open it at 12 a.m. And once you start, you need to complete it in 2 hours. That
Okay.
makes sense?
Okay, so once I study, like once I open up the exam portal, so I have 2 hours before I finish it, right?
Yes, yes.
Okay.
And you on your own pick up the 2 hour block. That
Okay.
makes sense?
Yeah, I get your point.
Because it's very hard to coordinate a common time over the internet. Yeah,
it's okay.
And because some of the students not here in US, yeah. So so you just pick the 2 hour block once you start. But the problem, just be careful, okay? Once you start, then you cannot say, oh, I turn it off. I will come back in another hour, finish. No, you need to, once you open it, you need to complete it in 2 hours.
Okay.
That makes sense?
Yeah, I get it now.
So plan well, okay? Also make sure you guarantee that you will have 2 hour internet access, everything, okay? And don't wait until last minute, don't wait until 10 p.m. Then for some reason cannot access internet, is it? Then it's going to be a big issue, yeah, okay.
All right, thank you very much.
Any other questions? If there is no other question, we will continue over the. And I forgot. Did we finish this part? Pandas data access. Anyone remember where did I finish the slicing and had get specific using the dot log? Using the dot log to retrieve the row. And did I also finish this? Anyone remember? Did I finish this one? Get a row by the dot log method? I kind of remember we finished, is it this one? The dates, I don't recall if I already finished it. So how about let's just start in here, okay? In case we also needed to bring off our memory back. So anyway, so this is a data frame. And if you recall Pandas data frame, Panda data frame, we said it is nice compared with NumPy as, and generally speaking, we consider 2-dimensional, is it? And compare with NumPy array, the array, is it? And it has something special. Who still remembers So how about this is our first quiz question. Quiz question. So for Pandas data frame, how do we locate row and column? Is it so row and column, they have some special thing you can do, is it? So anyway, so compare data frame versus NumPy array. What are the special things? Anyway, for Pandas, including series, it has something very helpful. And
You need a label?
Yes, very good, very good. Okay, it's also kind of like a dictionary, is it? Python's dictionary. So it has a label. Is it a label? And we call them what for Pandas data frame? You have index label. You also have what? Column can also have label. Is it? The default is number, is it? But you also have the labels. That's why we can also use a label to access certain items, is it? So in these cases, in this DF data frame case, this is what? This is index. Hold on, let me admit the student. I need to admit. Okay, so here we have the index. This index is aligned with what? With date time. Is it? It's date time index. Serves as index. And here you have what? You have column label. Is it column label? Okay. And you can also retrieve that. Is it? So anyway, and then so we know that this is the data frame, and the dates is what? The dates is a series, is it? And you can use the regular using indexing. This is to do indexing. Is it using what? Here you didn't use label name, is it? You just use the position, is it? You can still use the position. Okay, so the dates 0 gives you what? Gives you this one. Is it? You get this specific one. Is it? Hold on, I need to admit the student. Admit. And then next, let's see over here. Now here, so this is a data frame, then you call the dot loc. Is it dot loc? And you loc, hold on, I need to get to the student. You loc with what? You use the label. Is it? This over here, you kind of do indexing. Indexing with label. Okay, so be careful because date 0 is what? Is this one? Is it? Is this one? And this one is what? Is the index label. Is it? Index label. So with this dot loc method, okay, be careful. You need to plug in with the label. Okay, with the label. Okay, so this is a quick review. Let's see. Okay, I need to admit the student. So we kind of get the idea, okay. And what next one? Over here, did you use it called the loc again? Is it? And over here for the first, because here to use comma within the brackets, is it? For the first dimension, it does what? Does the slicing. So that means you're going to take all rows. For the second one, is it? And here, once again, you use what? You use column label. Is it? To do column indexing. Hold on, let me admit the student. Okay, so we kind of understand this. And here shows more example with the look. Okay, and here you use row for slicing and the column is to do indexing. Okay, indexing because over here it's not colon, it's comma, is it? And with brackets, is it with brackets? Okay. And you can also locate specific item, is it for the first dimension? It also do the label, is it using label to locate? Okay. So over here to once again shows is that you can also get a specific item, okay. And it also has the dot at, okay. And here, basically these two will give the same result. As here you call dot low, here you call dot at. And for pandas, it says dot at is faster access for a scalar. Okay, so it's faster compared with the dot log. So if you care about the accessing speed a lot, you can call the dot at. And Pandas still allow you to use selection by position. Okay, position means 0, 1, 2, 3, 4, the user index number, etc. And if you want to do that, you do the dot ilog. Okay, use the ilog. And then this means what? The third row, is it? The third row, and it gives you all of the item for all of the columns, is it? And over here, you can also do using position to do slicing, is it? But then you need to once again use ilog, is it? Here you slice from the fourth one, the fifth one, not including the sixth one. Does it include? Let me double check. Yeah, it doesn't include. Okay, because for the dot log, I remember we can double check. Okay, the dot log it's including the ilog. This one is excluded. Okay, and here it utilizes two items. Is there two columns? First one, second one, not including the third one. Okay, and we can also do indexing within ilog. So here is specific item. Is it on both dimension you do indexing, but you select a certain range. Is it? So you have the square brackets on both dimension. Okay, on both dimension. Okay, and be careful. Okay, here when you do slicing, you don't have brackets. That's then comma. Second dimension also slicing. And if you take a look here, for this indexing, then you have brackets separated by comma. Okay, and here you have colon. Okay, so be careful about the subtle difference. Okay, and then next. And here it says so you can also slicing, is it using ilog? Is it nothing new? Okay, and you can also slicing column using ilog. Okay, not a lot of new things. And the same thing here says, if you want faster access, you can do dot iat. Okay, dot iat. So similar as dot ilog, but it's faster. Okay. Okay, so that's regarding the general slicing and the indexing using dot log, dot ilog, dot add, dot iat, and you can also explicitly just use the regular indexing. Okay, and what next? Just like a NumPy array, Pandas also allow you to do Boolean indexing. Okay, Boolean indexing. So what over here to try to show is using a single columns value, is it? So using single columns value, how do you access? You can do df dot the specific column. So this is a column label. You can directly use dot to access its label, is it? And then you apply the condition. Here says greater than 0. Then you're going to select all of the items, is it? Hold on, we have one student coming. Okay, and if you take a close look, you will find all of the values from column A are greater than 0. As a greater than. And it doesn't matter for all of the others, but it just to present all meet these conditions values. Okay. So this is Boolean indexing. And what next one shows is, this is regarding the whole data frame greater than 0, is it? And so for B, for this B, basically then it's not greater than 0, it's less than 0, is it? It's not going to exclude it out, it just shows the name. Okay, it just shows, but it does provide you all of the values that are greater than 0. For all of the others that's not meet the condition, they just present the name, okay? And the other ones, this is in method. We can also use this kind of as a do filtering, okay, do filtering. Anyway, so here it makes a deep copy of that data frame. Then what over here does, and if you recall the previous data frame, this is a data frame, DF, kind of, okay, not all of them, but just part of it. It has A, B, C, D, 4 columns, is it? And then let's come back here. What does it do? So it suppose just has 4 columns. 4 columns, is it? And here it says for DF2 and the E, what does that mean? Then did you see it add a new column? Okay, you can also do this. And the column label is E, is it? If you take a look, it does have. And here are all of the corresponding column values, okay? So that's what that part means, okay? And then what it does want to do, the finding is for the column in, E is a new column. It want to find contain 2 and 4. Select the values. Okay, so if the item has 2 and 4, I'm going to select. Is it kind of like that? And based on this is a condition. Is it based on this condition? So if this is true, then I'm going to select. So did you see? So it's based on E, is it? If it has 2 certain items, if it has, then I'm going to select all related rows. Is it? That's what. So this is quite useful. Is it? A lot of time you want to do some conditional selection. Is it? Then here is the approach, and you can use to achieve this goal. Okay, this shows is in. And what next one? Let's see. Over here, is it? Over here, it's S1 is Pandas series, and with this list of items, what is the index? The index it says from the date range, starting at 2013, January 2nd, and you pick 6 days. Okay, and if we take a look, this S1, yeah, it picks 6 days. Is it from January 2nd all the way to January the 7th? And it has the value go to the corresponding column, is it? And This is S1, okay. Then over here, what it shows. And if you recall the previous DF, this is what the previous DF has. Is it? That's the DF data frame, okay, has 4 columns. And then here to add a new column. So that shows you can sometimes add some new column. Add a new column with what? With a series. So add a new column with a series. Because we just define S1 as the series. Is it? And the series, if you recall, the series started January 2nd. But your original data frame started at what? January the 1st. Is it January? So you're kind of missing an item. Is it? So it will automatically fill that missing item with the net value. Okay, so that's how it works. But it will still do automatic matching, okay, for the corresponding index label. Is it use indexing label, okay, to do the matching, okay, to do this. Okay, that's the add a new column, okay. And next is that you can also change the value. So regarding that data frame, here we use that at, okay. And the first row, first column, so that should be that item, is it? You reset it to 0, is it? And let's take a look. Previously, it shouldn't be 0, is it? Previously, it's 1.02. Now it's updated. So you can use a specific to do the updating, okay? Because when you do data processing, a lot of time you may want this kind of features, is that you can do that. You can also, here it says you can also use position to update the value, okay? So use I at, okay? And here it just shows we can also by assigning with a NumPy array. Is it? So here is a NumPy array has 5. Is it? And the length is the same as that data frame. Is it? So you're going to have a bunch of 5 be generated. Is it? And this in Python means repeating. Be careful, okay, it's not math, okay, in Python. That means repeating, okay. Repeating. Okay, over here it's what? The column D. Is that you want to update it with all of these new values, okay? You can also use NumPy array here, just show, not just a series. As a previous example shows, you can use series. Is it to update? As a here, just you can also use NumPy to assign value, okay? Just shows multiple ways, very, very flexible. And what the next one try to show, you can also use condition, where condition to do the setting. Here on df2 is df's copy, is it? And says for all of the items that are greater than 0, positive, you're going to negate it. Is it? You're going to negate. So here it shows, is it? So that's also fine. Okay, and then what next one try to show, how do we deal with some missing data, okay, and also re-indexing, okay, re-indexing. And the first one is try to show us is what the original, so anyway, so this is our original data frame, is a data frame. And then here is our df1. What the df1 will be formed is that with the original data frame, this data frame, and it says re-index. Okay, the index is going to be dates from that dates series, is it? And you get from 0 to 4, is it? So the 5 item, 0 to 4, okay. So over here it's slicing, so the last one excluded. So that's you do the indexing. Is it indexing from the dates? That's the series previous. And for column, it says, okay, list of this column. So this is DF's column, is it? And then you're going to use it to create a list. Is it? So basically, you're going to have A, B, C, D. Is it something like that? A list. Okay, so and plus what? So here is, that's not a plus, that's append. Append a new column with E, is it with E? So that's regarding the column, okay, regarding column. And then what it does, the next one, what it try to show it to find the specific item, so it does some slicing, is it? Look, the first one, is it? And the column E, is it column E? And it's set the value to what? To 1, is it? Set the value to 1. Because initially the E column doesn't exist. If it doesn't exist, it's going to be filled with all net value, is it? With all net values, is it? But I'm going to change it, as I change it. And what over here it shows, the data frame, this method reindex can create a copy of the data frame. And with the new specified index label and column labels, okay? And then you can do some reassignment. Okay, so that's regarding reindexing. And what next one also show how do we deal with missing data, as a missing data. So to deal with missing data, you can have a method on the data frame called drop NA. Okay, and you can specify how you are going to drop. Here it's how I'm going to pick any. So if there is any nav value, I'm going to drop it, okay? So over here, if you take a look, is it? So the first row has name, and the third and the fifth has has name, is it? So I'm going to drop what? Drop all of those. So that's why you only have this single row left. Okay, single row left. But this is not going to impact on the original data. Yes, it's only on view. Okay, only on view. If you do want it to happen on original data, be careful. Then you need to plug in the keyword argument that in place equals true. Then the original df1 is going to also just have this single row. All of this 3 going to be removed. Okay, so be careful. And by default over here, you didn't specify. That means it's only on view, okay, not on df1 itself. If you do want to happen to on this, you need to have that in place equals true, okay? Plug in this keyword argument. Okay, that's drop NA. And a lot of time, okay, we not just going to drop, we can replace the nav value with some other value you want. Then in this case, you can specify fill NA, is it? And then you provide whatever that value is with this keyword argument value, okay? So over here, just said, okay, I'm going to plug in with all of the nav values with 100. That's also useful. And another one here is an A. You can also find, because this also helpful for a lot of times. You want to find out all of the nav values where they exist. Then you can use is an A. That will return the true values for that specific spot. Okay, it's quite useful that you can pinpoint where it is with the true false. Okay, so that's regarding the nav values handle the missing data. Okay, and what next one try to show is some operations on pandas data frame. Okay, and the mean sum uses also related with descriptive statistic information, is it? So you can also call df data mean, is it? And the data frame generally speaks two-dimensional, is it? So by default, is it axis is 0, is it? When axis is 0, it's regarding the indexing, is it? So the mean value is conducted for the indexing. Is it for the, so that's why you get the mean value for each column. For each column. So it will add the different row value together and then find the average. Okay, so be careful. Otherwise, you can also specify. Is it? You can also specify the axis. So here's the axis is 1. Is it? That means what? You want to add all of the column data and then find the average. Is it? So you're going to calculate mean for each row. Is it? So the operation is on the specify axis. And if you don't specify, like here, by default, is it? So by default, axis is 0. Okay, the indexing one, not the column one. Okay. Okay, so this is regarding mean. Okay, and next, let's see, we can do some more here. Says. So here we have, this is a Pandas series, and the index is dates, and it also conducts shifting. Okay, so what we show is starting at 1, then 3, then 5. Is there 1, 3, 5? And starting at January the 1st, let's say January the 1st. But here it says you are going to do shifting to. So that's why the first 2 filled with nav values. Okay, be careful here. Okay. And then what next one? Okay, so here we have this data frame. So here we have this data frame as usual, that our data frame. And then what do you call? You call the sub. So this is arithmetic subtraction operation. Okay, so subtract what? Subtract that series. S is a series. Hold on. Let's just take a look. Is it? S is this series, is it? So what you mean here is you want to do what? You want to subtract that series from this data frame, is it? Along what? You specify the axis. The axis here says I'm going to use the index to do the subtraction. Is it to do subtraction? Okay, so this is your data frame, and this is the series. Along the indexing, is it? So here it has its index, here is the data frames indexing. but the first two are NaN for S, is it? And here for data frame, you do have values. And if you have values, you minus some NaN, and of course, you cannot do anything, is it? So that's why over here, the result shows, is it? It's all NaN for the first two rows, okay? Okay, so this shows you can do some operation. And what the next one also shows for pandas, you can also specifically call apply method. Okay, because sometimes you don't have that mean, not always want to calculate mean something. Is it? You want to apply maybe some customized operation method. Is it? Then you can plug in with, you call the dot apply method. Is it? Dot apply method, it does what? It does, we previously learned, is it? So NumPy's cumulative summation, is a cumulative summation operation, is it? And here it says use the default access, is it? So the summation you are going to do is summation of the numbers from the rows, is it? From the rows. That's what you come up with of the values, is it? Okay, so you can also, here just shows, you can also call apply, is it? And once again, here shows, is it? For the apply, you can plug in here even lambda expression, is it? With lambda expression. And you specify, is it? Whatever the option. So here is a lambda expression, okay? And then, what the next one try to show us is we can also do histogram to do some value counts, is it? So here we have the series, okay, some random number generated, is it? Okay, the series, and then you can do value count. Value count kind of give you histogram, is it? Histogram. So here it shows, is it? Okay, 4, you have 3, 4. You have 2, 3, you have 1, 6, 1, 5, is it? So it does counting also for you, okay? So that's what this value counts shows. Okay, what next one? Let's see. Some string method. We can also apply it for some string series, is it? So here you have the series. What the series has is some string, is it? And then you can apply the string operation, is it? So here it's called strings what? Lower, is it? So did you see it convert all of the letters to lower case, is it? So this is quite useful, okay? And next, let's see, for even for data frame, we can do similar. So here we have the data. So this anyway is Python's dictionary, is it? And you create Python data frame with the dictionary. We have the data frame, and we drop all the NaN values. Here you see we do the drop NA on the original data, is it? Okay, what next one I try to show us is with the address column. So over here, you get the specific column, is it? And on this specific column, what you're going to do? You're going to do string split, is it split? And generally speaking, regarding split, if you don't specify the token, you're going to do split. By default, it's white space. So by default, there's some white space. And here you specify what? You use A to do split. But I'm not going to get all out based on this split. I'm just get one, the first one out. Otherwise, what a split method returns is what in Python? It returns an array. Is it a number of items? Is it more than one? So anyway, here I'm just going to get the first one. Is it the first one? So you're going to get N, you're going to get K, you're going to A, L, B, you're going to get C. Is it? That's what this shows. And we can take a look at the result. Is it? Did you see it does only get what you specified with the split? Okay, so here once again shows a very nice operation. And what next one try to show? Okay, so here I'm going to the deeper copy with this column. Is it? And for the name column, a lot of time for data processing, you're going to do a lot of this kind of operation. Is it in the real world application? For the name part, what I'm going to do, I want to do some concatenation. So you can also call string concatenation. Concatenate was with what? With the whatever from the address column, and then add with the separated by what? Comma and space. Is it? And here did you see the name field does concatenated with the comma and then whatever from the address field. Is it? So a lot of cases like first name, last name, maybe you want to do this kind of concatenation, is it, to get to the full name. That shows how we can work here. Okay, what next one try to show? So this is regarding that MBA CSV file. Okay, with regarding that file, looks something like this. It has a column label with age. Is it? So here what it shows, you can also call replace. You replace all 25 with the string 25. And then you can do this assignment also. Is it? Assignment also. And what next one try to show is this also quite useful. Is it? And what next one try to show, you can also then use this as filtering. Is it? So here, then you find in this column, is it, all of the items that has that 25 string. Is it? So you will get true or false, is it, for this filter. Is it? And with true, then you can do the where. Is it? You apply the filtering. Is it? And apply that, and regarding you filter out of the 25. Is it? And if within of the data it has nav values, is it? Then you're going to drop it. Is it? So all of the values here, it won't have any nav values. Is it? So here just shows you we can combine all of those together, okay, to do some data cleaning, okay. So what next one shows us more regarding the string operation on Pandas, okay. So here we have this string series, okay, Pandas series. And with this series, and then once again, the pen not working. I don't know why it's not working. Let me close it. Okay, so you can call that extract. And here R means on raw string. Is it a raw string? And here, if you recall with regex, is it, this is for grouping, is it? And within it, if you have this square brackets, so it's included set. Is it included set? So that means you have A or B, is that you're going to extract it. And the second one, /D means digit. Digit, is it? So or meet that, you're going to extract it out. Is it? So what we will have in this case is kind of you're going to have that data frame as a two-dimensional, is it? And the first one matching all of the letters, the second one matching all of the digits, is it? But only the first two get extracted out, okay? So a lot of times that's also quite useful, okay? And what next one try to show is with regex. Previous we also learned. As there with regex, the question mark and the P, capitalize P, okay? So in this case, then we can refer to the corresponding group with whatever the name, okay? Okay, so anyway, so this is a regex search. Is it? The search, this is a string you're going to search. Okay, and here is a pattern. The pattern, is it? And I have two groups, is it? And this time, if you recall previously when we learned in Python, and then you need to use the group to get the corresponding one, is it? And here you give each of the group a name. The first one said, okay, the pattern is going to be some single letter and repeated. Is it? So definitely this John going to match. Then with a space, And what the next one is a single letter repeat, Is it? And then you give the matching pattern a name. So the first group, I name it as what? As name. The second one, I give it a name called phone. It's just you name it, just kind of like a label. It's kind of like the label concept, is it? So then did you see when you call the group, we didn't specify with 1 or 2. Previous we use 1, 2 to specify. And here you can explicitly use the name defined by the question mark and P. Okay, this is the name group, is it? And then this is quite useful, is it? And regarding this, you see, when we have some Pandas series, is it? And you can do the extract, is it? You can apply this technique, question mark, and then give whatever a name, is it? And here we have that N, is it? And then did you see with that N? So this is our N, is it N? And then you can get its index and its column name, is it? And then you can use data frames, data lock to extract the corresponding column or the corresponding label index, the row. Is this? So here it just shows more friendly, okay? And you can define it with a name, is it? Okay, so next is regarding merging, but we kind of run out of time, okay, because I don't